Hello everyone. In this video, I'm going to walk through question Q18 of part 1 of the RF homework exercise. The first question asks for the cutoff frequency of an air filled waveguide uh, that is converted to the first question asks for the cutoff frequency of the waveguide if it is uh, filled with a non-magnetic dielectric material that has a permittivity 6 times higher than that of air. Oh, so this question is very straightforward. So first of all, I make sure you can see the screen. Now I'm going to stop present sharing. Now you're looking at the right board. So the first question, question 18, part 1. So F C is equal to phase velocity and then ma and b square. So initially, when everything is normal, you have and then m over a square plus nb square, and this will end up with 2.4 gigahertz. But once you fill the waveguide cavity with another material which has a permittivity 6 times that of air, then you will get 2 m over a plus n over b. So this will give you 2.4 divided by square root of 6. And this will end up with 0.978 gigahertz. So this is the answer of the question. Now, okay, done. So I'm going to switch you to the right board. Now, this question is done, and we are going to work on this question instead. So we are now dealing with part B of the question. Part B, part 2 of the question. So you are given the waveguide dimension and the operating frequency. And assuming the guide is made with air, so they ask for the highest possible mode and the intrinsic impedance of this. So against what they are asking for, the higher possible mode. This means the cutoff frequency. That is below but closer to 11 gigahertz. Okay, so I'm going to stop sharing and we are going back to the whiteboard. So in this question, you have a waveguide and the height of the waveguide is B, which is B equals to 2.5 and the height A equals to 5 cm, 2 cm. So frequency is 11 gigahertz. So what you can do is you have shown the cutoff frequency is 11 gigahertz. And then the speed of light and then m divided by 0.05 square plus n plus 0.025 square. So if you do a log of simplification, when this one move to the left and this one move to here, and you will take square, and then you will end up with m square and divided by 0.25 square, and then n square, and then 0.025 square. So in this case, if my calculation is right, you get 1/4 yeah. Let me see. So m square 0.025 plus n square 0.025 square. Is it correct? Okay, this one should be 25. Maybe just make it like this 0.25 times 2 and then square. So if you do this, then both expressions have 0.025 at the bottom. So you move this to here. So you end up with m squared divided by 4 plus n squared. So now you need to try another. So precisely, right, this one is not, this is 3.3611. So yeah, if n is equal to 1, then m is equal to this one times this. This. So it will be 4 3.3611 minus 1, and this one will be 3.66. So this implies that M is equal to 3. Um, so, in other words, in terms of the cutoff frequency, F, C, T, E, 3, 0 is going to be 3 times 10 to the power 8 divided by 2, and then 3 0.025 square plus 1 0.025 square. And then all you get is 10.817 gigahertz. So this is close enough to 11 gigahertz. But what if n is equal to 0? And then m is going to be 1.2 square. So which means 6.66. So which means 2.5927. So this means m is equal to 2. So obviously, if n, sorry, in this case, this is 1, right? I got it wrong. So in this case, FCTE 1 to 0 e times 10 a divided by this, and then 0. So this will end up with 6 gigahertz. So this one is not close to enough to 11 gigahertz. So we, in this case, we assume this is the answer. Okay, so part 2 is done. So I'm going to switch back to the presentation mode. Now, this one is done. And I'm going to look at this question. The air-filled rectangular waveguide, the cutoff frequency of TE10 mode is 5 gigahertz, whereas TE01 mode is had a cutoff 12 gigahertz, and calculate the dimension of the guide, and then the cutoff frequency of the next three higher modes. Oh, that's should quite easy. All you need is to set up the equation. So I'm going to flip back to the whiteboard mode. So we are now looking at part 3 of the question. Okay, so stop sharing. So part 3. Part 2, I have some leftover job. I also need to calculate the intrinsic impedance. So I need to do this. Right? Let's make sure I got it right. and then 1 plus fc over f square. So B77 1 minus 10,817 and then 11 square. So if you do it carefully, then this will become like this. And TMO, the formula is similar, except that this square root expression is moved to the top. And in this case, you get this. So if you do it carefully, you get 68.48 ohm. So this is the answer for the final part of part 2 of this question. Now I'm going to um, focus on part 3 of the question. Okay, so part 3, yeah, I'm going to erase this. Part 3. And according to the questions, uh, first we need a formula. It doesn't matter if TEMO or TMO. The formula will be the same. M over A squared plus N over B squared. And condition 1, in TE 10 mole, you have 5 gigahertz. So I will use 10, sorry, this one, 9. 9, and then times 10 to the power 8, and then 1 0. 1 over 8 square plus 0. So this will, yeah, we have one equation and one unknown. So it's very easy to prove that uh, A is equals to P centimeter. Okay, now I'm going to look at 1 0, 0 1, T 0 1. The cutoff frequency is 12 gigahertz. So I'm going to use the same formula for different condition. So 0 plus 1 over B squared, and this will end me up with B equals to 0.0125. So the first part of the question has been done. Now the next part, the next highest order mode. So you have what you need to do is to find out the cutoff frequency. Uh, that is larger than either both of them. So larger than 20 gigahertz. So let's see. Let's see. F C T G 20 and see what we are going to get. So this is slightly higher than this one. And let's check what kind of um, cutoff we can get. So 3 times 10, 8, and then minus 2. And then we have already found the dimension A and B. So 2 0.03 square plus B 0. So 0. And let's check the frequency. I need this 10 gigahertz. So 10 gigahertz is obviously less than 12 gigahertz. This cannot be right. And then FTE30. And let's see what we are going to get. 30, the chance of getting the answer right is high. So from what I can get, I got 15 gigahertz. So is the chance is high. So now let's try CTE11. So this is also in terms of order, is higher than both of them. So we can check 1, 0.02 square, so 3, and then plus 1 over 0.0125 square. And let's see what we can get. From what I get 13 gigahertz. So this one is also, it looks, it makes sense. So the next one, I think I can guess it should be F21. No, 21 and see what we are going to get. 2, 0.3 there plus 1, 0.0125 square. So it all depends on the cutoff frequency, right? Let me give some calculation. BA divided by 2, and then 3, and then plus 1. So I got 15.6 gigahertz. So this also looks good. This also looks good. So I presume we have enough. Yeah, if we increment this one a little bit, it will be higher than that. So I believe these are the next demo. If you try F C T E 02, you will get 24 gigahertz. So this cannot be right. Uh, if the order is higher, then it's even worse. So it cannot be right. So I believe the next three higher order mode is 3011 and 21. Okay. Now let's go back to the question. The answer 201130. So I don't think the answer is right because at 2 gigahertz, at TE20 mode, the cutoff frequency is 10 gigahertz. When we actually want the cutoff frequency of the next three higher TE, oh sorry, TE mode, still correct, still correct. If you talk about TE mode, it's still correct. If you reserve to TE mode only, this is also correct. So TE0, TE11, and TE30. Okay? So this is all we have done. Okay? So my answer, I'm going to switch board to the whiteboard. The question asks for only TE mode. So this is correct. And this one, so you look at the value. So the next three, so next three is obviously this one. So this one can be ignored. So 203011. So the question is correct. The provider answer is correct. So I'm going to um, switch you back to the question. So question three is done, and we are going to look at part four of the question. Given the dimension of the air filter rectangular waveguide for which the cutoff frequency for TE 2M11 and TE030 are both equals to 12 gigahertz. Again, this kind of question is super easy. At 8 gigahertz determine whether the dominant motion will propagate or evanescence uh, in the waveguide. So propagate, in order for the wave to propagate, the cutoff frequency, the propagation constant has to be real and positive. If any cutoff frequency, there is a complex number. If any propagation constant, there is a complex number, then we have even distance. Okay, so now we are not going to look at this. So give me a few seconds. Question 4. And according to here, TEM11. So the cutoff frequency is 12 gigahertz. Okay, I will switch you back there. So you are looking at the right one. According to the question, uh, this you TE11, you have a cutoff. So the TM11, you will have a cutoff 12 gigahertz. So 10, 8 divided by 2, and then 1, 1. So 1 over A square plus 1 over B square. So this is equation number 1. And TE30 will have a cutoff also at 12 gigahertz. B over A square plus 0. So I don't want to write too much now. So in the second equation, you have one unknown only. So you just immediately resolve it from 2. The value of A, the value of A is uh, you need to solve it. So 2 times 12 times 10, 8 uh, divided by 3 times 10 to the power 8. And uh, and then times 3. So from what I can get, A is equal to 0.0375 meter. So you have one variable A. You just substitute the value of A back to equation 1. So you get this 1 over 0.375 square plus 1 over B. So from here, you will get B equals to 0.01328 meter. So this is the dimension we need. Now the dominant mole is TE10. So in other words, the cutoff frequency for TE10 is V 101 over 8, 0.0375 where and then 0. And in this case, you will most likely get the cutoff frequency to be 4 gigahertz. But the wave, according to the question, a so F is equal to 8 gigahertz according to the question. So this means the wave will propagate. Wave will propagate. Okay, so this question is done. We are going to switch to the next question. Now you are now looking at the next question. This one is done. We are looking at this one. And TMO operating at 5 gigahertz is um, traveling in air-filled rectangular waveguide. If the E of Z is this equation, sine 2 pi x divided by A times sine pi times B divided by B times cosine omega t minus 10 Z. Unit is voltage per meter. This is the usual unit for electric field. The first part of the question, part A, it asks for cutoff frequency. So in order to know the cutoff frequency, you either use the value of A and B to calculate it, but A and B is not given. Or equally, we can use the propagation constant, K of Z, to work it out. Okay? And the field component of X of Z and E of X. Remember, this is TE mode. There shouldn't be any uh, longitudinal component of magnetic field. So as you can see from the answer of the question, right? Uh, part B is actually the first part, and part B is zero. And it also asks for calculation of the electric field in the x direction. So that's very easy. Yeah, you just need to use some formula. I've already told you before. Okay, so give me a second. I'm going to erase the whiteboard, and then I will switch you back to the whiteboard mode. Part 5. So you are now looking at part 5 of the question. Okay, so TMO, this implies HD is 0. D of D is given by sine 2 pi x divided by A, and then sine pi y over B, and then cosine omega t minus tan of V. So obviously, the equation has already given the propagation constant. This is k of z. K of z is equal to 10. So this is the very variable information. Now, you need to use the formula. Uh, we know that k of z is equal to k. Yeah, if you are not familiar with the subject, you can just take a look in the lecture notes. So I have already given it. Okay. So this is the formula. So if you plug in 10 and then 2 pi uh, lambda, right? About F over C. So you can just write uh, phi. What is the frequency? Phi giga. So phi by 2. And then 1 over FC divided by 10. So you just solve this equation for FC. Let me check. I got 4.9772 gigahertz. So the answer is consistent with the provided answer. Now, the second part of the question, it asks for, so this is part A, part B, asks for h of z. H of z, as you already know, it cannot be any other value other than 0. Otherwise, it wouldn't be called TMO. And E of z. Then you need to use some formula. I have derived for you one of the formula that I have derived it to you is here, k of z minus k, and then now remember h of z is equal to 0, so this term can be forgotten. And other thing is very easy to get. For example, in this case, uh, we get minus kv over kc square, and then kz has already been obtained. It is this value 10 kc. So you need to calculate kc first. Kc is equals to 2 pi fc divided by uh, c. C is the velocity of the light. And then 2 pi, yeah, fc we have already calculated, 4.9772, and then kick. And then uh, partial z partial x. So we need to differentiate this expression with respect to x. So we will do that. Uh, then you will get 2 pi a. The way to look at a parameter for a. Let's check the question. So a is not given. So a is not given, and then cosine 2 pi x over a, and then you get plus here because differential of sine is cosine minus. You got plus here, and then the rest will be independent of x. So we just copy it. Omega t minus 10e. So you just need to work out this portion, and then so this is the answer. This is your answer. Yeah, you use 10 divided by 104.24 square. then the answer will match exactly uh, to the numerical uh, value of the suggested answer. Okay? So if you have any other question related to question 8, Q18 of part 1, of part 1 of the RF technology exercise, please leave your question to the comment section. Thank you.